On the morning of May 31, 1889, cold mist hung low over the Conemaugh Valley. Clouds pressed against the ridges that enclosed the narrow basin where Johnstown spread along the river banks. The air carried the soft metallic echoes of the mills, still warming after the night. Rain had been falling for days, steady and indifferent, soaking into ground that could hold no more water. Johnstown was an industrial town of 14,000 people, built where the little Conemaugh River met Stony Creek. Steel mills lined the water's edge, their furnaces beginning to glow as workers arrived for the morning shift. Smoke rose slowly from brick chimneys, merging with the gray overcast. The smell of coal smoke mixed with the damp earth. Wooden homes stood close together on the flats and partway up the hillsides, their foundations just feet from the water. Boardwalks connected the main streets, raised above the mud that accumulated during wet weather. The rivers were already high. The little Conemaugh, which normally ran shallow enough to wade across, now moved fast and brown, carrying branches and debris from upstream. Stony Creek, fed by mountain tributaries, had risen past its usual banks. Puddles covered Washington Street. Water pooled in the rail yards where the Pennsylvania Railroad maintained its repair shops and switching stations. The streets were soft with mud. Children on their way to school stepped carefully around the deeper pools. The Cambria Iron Works dominated the eastern side of town. Its blast furnaces and rolling mills employed thousands of men who worked in 12-hour shifts. The works stretched along the riverbank, a complex of brick buildings, wooden sheds, rail sidings, and stockpiles of coal and iron ore. Steam engines powered the machinery. The steady rhythm of hammers and rollers formed the town's constant background sound. On this morning, as on every morning, the works came to life with the lighting of furnaces and the movement of materials. Above the town, 14 miles upstream in the Allegheny Mountains, the South Fork Dam held back a reservoir that stretched 2 miles long and a mile wide at its broadest point. The structure was an earthen embankment, 72 feet high at its center and 900 feet across at its crest. It had been built decades earlier to supply water for the Pennsylvania Canal system. Now it served as the centerpiece of a private fishing and recreation club, its shoreline dotted with cottages and boathouses, where Pittsburgh's wealthy industrialists spent their summers. The dam was quiet that morning. Water lapped at the embankment's sloped face. The reservoir surface was smooth and gray, reflecting the low sky. A caretaker's cottage stood near the eastern end, smoke rising from its chimney. No one in Johnstown gave the dam much thought. It had been there for years, a fixture of the landscape, mentioned occasionally but rarely considered with any seriousness. Some residents knew it existed, others had never seen it. The distance between the reservoir and the town seemed sufficient to separate their daily concerns. The valley began its day with the rhythm of work. Mill whistles sounded at 6 o'clock, their notes carrying across the water. Horses pulled delivery carts over the wooden bridges that spanned the rivers at multiple points. Shop owners opened their doors on Main Street and Washington Street. The smell of bread from the bakeries mixed with the coal smoke. The rain continued, steady and cold, tapping on tin roofs and pooling in the ruts of unpaved streets. The rivers kept rising, but they had risen before. Flooding was a regular occurrence in spring. The water would crest, then recede. The mud would be shoveled away. Life would continue. By mid-morning, the rain intensified. The sky darkened to a uniform gray. Visibility dropped. The ridges that enclosed the valley disappeared into the low clouds. Water ran down the hillsides in streams that had not existed the day before, carving new channels through the thin topsoil. The sound of rain on rooftops became a steady hiss. People moved quickly between buildings, collars turned up, shoulders hunched. The streets emptied except for those whose work required them to be outside. At the South Fork Dam, the reservoir continued to rise. Water crept up the sloped embankment, inch by inch, as rain fell directly into the lake and as streams from the surrounding mountains poured into the basin. The surface, now pockmarked by rain, moved in slow currents toward the spillway on the eastern end. The spillway, a channel cut into bedrock, was designed to carry overflow away from the dam, but the spillway was partially obstructed, and the water could not drain as quickly as it arrived. In Johnstown, the morning passed. Workers at the Cambria Iron Works continued their tasks, moving between the heat of the furnaces and the cold damp of the yards. Children sat in schoolrooms, listening to lessons while rain streaked the window. In Johnstown, the morning passed. Workers at the Cambria Iron Works continued their tasks, moving between the heat of the furnaces and the cold damp of the yards. Children sat in schoolrooms, listening to lessons while rain streaked the windows. Shopkeepers watched the rivers from their doorways, noting the height of the water against the bridge pilings. Some began moving merchandise from lower shelves to higher ones, a precaution taken during every heavy rain. The day felt like any other spring flood day, inconvenient but manageable, a matter of waiting for the rain to stop and the water to recede. No alarm was raised. No warnings reached the town. The telegraph lines that connected Johnstown to the upstream villages were functioning, but no message of unusual danger had been sent. The rain continued. The rivers rose. The valley went about its business, unaware that 14 miles upstream, the reservoir behind the South Fork Dam was now within 2 feet of the dam's crest, and the structure was beginning to show signs of strain. Liddy. The Conemaugh Valley was shaped by forces older than human memory. Steep ridges enclosed a narrow floodplain, the result of millions of years of erosion and tectonic compression. The Allegheny Mountains, weathered and rounded, rose sharply on all sides. Water from the surrounding highlands funneled into 2 main rivers that converged at the center of Johnstown, creating a natural bottleneck. During periods of heavy rain, the water had nowhere to go but up and out, spreading across the low ground. The valley's geology offered no natural resistance to flooding. The soil was thin, underlain by bedrock that prevented deep absorption. The hillsides, stripped of much of their original forest cover by logging operations in the mid-1800s, shed water quickly. Erosion was constant. The rivers, fed by dozens of tributary streams, responded rapidly to rainfall. A storm that lasted hours could raise the water level by feet in a matter of minutes. Into this landscape, industrialization had brought profound changes. By 1889, Johnstown was a center of steel production, its mills supplying rail and construction materials to a growing nation. The Cambria Iron Works alone produced rails for thousands of miles of track each year. To support this industry, the town had expanded rapidly. Homes, warehouses, and rail yards now occupied land that once absorbed floodwaters. The natural floodplain was covered with buildings and compacted earth. Wooden bridges spanned the waterways at multiple points, their stone piers constricting flow during high water. The rivers, once allowed to spread and meander, were now confined to narrow channels. The effect of these changes was cumulative. Each bridge pier, each building built close to the water, each section of riverbank reinforced with timber or stone, reduced the valley's ability to handle excess water. The hydrology of the basin had been altered in ways that were not fully understood. Engineers and town planners focused on expansion and production, not on the consequences of constraining natural drainage. Flooding was accepted as an unavoidable inconvenience, something to be endured rather than prevented. Above the town, the South Fork Dam represented a different kind of vulnerability. The structure had been constructed between 1838 and 1853 by the Commonwealth of Pennsylvania as part of the main line of public works, a canal system designed to compete with New York's Erie Canal. The dam created a reservoir that supplied water to maintain canal levels during dry periods. It was built using the technology of its time, an earthen embankment composed of clay and rock, compacted in layers, with a spillway cut into bedrock on the eastern side to handle excess water. An iron drainage system ran through the base of the embankment, consisting of 5 cast iron pipes, each 2 feet in diameter, designed to relieve pressure and allow controlled discharge of water. The design was sound for its intended purpose. The dam held water reliably for years, supplying the canal system without incident. But the canal system itself became obsolete with the arrival of the railroad. By the 1850s, rail transport had proven faster and more efficient than canal boats. The state abandoned the canal network, and the South Fork Dam fell into disuse. In 1862, during a period of heavy rain, the dam was overtopped and breached. The embankment failed, releasing the reservoir in a sudden flood that caused damage downstream but resulted in no known fatalities. The dam remained breached and abandoned for nearly 2 decades, its reservoir drained, its purpose forgotten. In 1879, Benjamin Ruff, a railroad contractor and entrepreneur, purchased the dam site and surrounding land for $2,000. Ruff saw potential in the location as a retreat for Pittsburgh's industrial elite. He formed the South Fork Fishing and Hunting Club, recruiting members from among the city's wealthiest businessmen. The club's vision was to create a private mountain resort centered on a restored reservoir stocked with fish and surrounded by cottages and recreational facilities. Ruff oversaw the repair of the dam. The breached section was filled with earth, stone, and whatever material was readily available, including hay, tree stumps, and loose rock. The repairs were done quickly and cheaply, prioritizing the restoration of the reservoir over structural integrity. The original cast-iron discharge pipes at the base of the dam were not replaced. According to later testimony, Ruff considered the pipes unnecessary and chose not to invest in their reinstallation. This decision eliminated the dam's primary mechanism for relieving pressure from within the embankment. The spillway, the secondary means of managing excess water, was also compromised. The dam's crest was lowered by approximately 2 feet to accommodate a carriage road that allowed club members to drive across the top of the embankment. This reduction in height decreased the reservoir's capacity and brought the water level closer to the point of overtopping during high water. Additionally, screens were installed across the spillway to prevent the club's stocked bass and trout from escaping into the downstream waterway. These screens, made of iron rods and wire mesh, became clogged with debris during periods of inflow, further reducing the spillway's discharge capacity. Engineers who inspected the dam during the 1880s expressed concern. Daniel J. Morrill, president of the Cambria Iron Company, visited the site and noted the absence of the discharge pipes. He raised the issue with club officials but received no commitment to repairs. John Fulton, a civil engineer employed by Cambria Iron, inspected the dam in 1880 and concluded that it was unsafe. He observed that the embankment lacked a stone or masonry facing to protect against erosion, that the spillway was inadequate, and that the absence of the central pipes posed a significant risk. Fulton's concerns were documented, but no action was taken. The alterations made to the South Fork Dam were incremental, each one seemingly minor in isolation. But together, these changes created a structure with drastically reduced capacity to manage high water. The dam could no longer relieve pressure through its base. Its spillway, narrower and partially obstructed, could not discharge water as efficiently as the original design intended. The embankment itself, composed of loosely compacted earth without protective facing, was vulnerable to erosion if water flowed over the top. Maintenance was irregular. The club hired a caretaker to oversee the property, but his duties focused on groundskeeping rather than engineering oversight. Seepage was observed but not addressed. Small leaks that appeared on the downstream face were filled with mud and straw, temporary measures that did nothing to address underlying structural weaknesses. By May 1889, the South Fork Dam had been holding water for 10 years since its repair. The reservoir was full, stocked with fish, surrounded by well-maintained lawns and cottages, but the structure was fundamentally compromised. It was not designed to withstand the conditions it would face on May 31, 1889. Rain had been falling across western Pennsylvania since the evening of May 28. It was not a violent storm, but a slow, persistent system that settled over the region and remained stationary for days. Weather observations recorded at Pittsburgh showed continuous precipitation, with brief pauses followed by renewed downpours. The ground, already saturated from earlier spring rains, could absorb little more. Water ran off the hillsides in sheets. Streams that normally carried just inches of water were now several feet deep, their currents fast and turbid with sediment. By the morning of May 31, the South Fork Reservoir was rising at a rate of approximately 1 inch per hour. The caretaker, John Park, a young engineer employed by the club, walked the length of the dam repeatedly, checking for signs of trouble. The water level was now within 2 feet of the dam's crest, closer than Park had ever seen it. The spillway, choked with debris accumulated over the winter and spring, was discharging water, but not enough. Logs, branches, and matted vegetation pressed against the fish screens, forming a dense barrier that reduced flow to a fraction of the spillway's capacity. Park organized a crew of workmen and Italian laborers who were employed at the club for grounds maintenance. They worked to clear the screens, using long poles to dislodge logs and pull away tangled debris. The work was difficult and dangerous. The current at the spillway was strong and the water was cold. Progress was slow. For every log removed, more debris floated down from the upper reaches of the reservoir. By late morning, it was clear that manual clearing would not be sufficient. The water continued to rise. Park ordered the crew to attempt cutting a new spillway through the embankment's western end, hoping to create an additional outlet for the water. Men with picks and shovels began digging into the compacted earth. The clay was dense and heavy, resistant to their tools. Water seeped into the cut as they worked, turning the soil to mud. The rain did not stop. The reservoir kept rising. By noon, water was lapping at the base of the carriage road that crossed the dam's crest. Park sent riders to the downstream villages with warnings. One man rode to South Fork, the village immediately below the dam, to alert residents that the dam might fail. Another rider was sent toward Johnstown, though the distance was great and the roads were poor. Telegraph messages were sent from South Fork to stations downstream, but the network was unreliable during storms. Some messages got through, others did not. In the villages, the warnings were received with mixed reactions. The dam had stood for years. There had been warnings before during heavy rains and nothing had happened. Some people moved to higher ground. Others remained in their homes, watching the rivers rise. At the dam, the situation worsened. By early afternoon, water was flowing over the top of the embankment. At first, it was a thin sheet spreading across the crest. The flow deepened. The earthen surface, unprotected by stone facing or vegetation, began to erode. Small channels formed and widened. The clay, once compacted, loosened under the pressure of moving water. Chunks of earth broke away from the downstream face and tumbled into the ravine below. Park and his crew abandoned their efforts to dig a new spillway. The water was now too high and the embankment was visibly deteriorating. They retreated to higher ground and watched. The sound of the water changed from a steady rush to a deeper, more ominous roar. The channels carved into the dam's crest widened into gullies. The flow increased. The embankment shook. At approximately 3:10 in the afternoon, the center of the dam gave way. The collapse began with a section of the crest sliding into the reservoir. The breach widened rapidly as water poured through, carrying with it thousands of tons of earth, rock, and debris. The sound was described by witnesses as a prolonged, grinding roar, punctuated by sharp cracks as sections of the embankment fractured and fell. Within minutes, the breach had expanded to more than 400 feet across. The reservoir, which had taken years to fill, began to empty. The water surged through the opening with immense force. It carried everything in its path: sections of the embankment itself, trees torn from the reservoir's shoreline, debris that had accumulated at the spillway, and loose material from the surrounding hillsides. The mass moved down the narrow valley like a moving wall, its height varying with the terrain. In the narrowest sections, where the valley walls closed in, the water rose as high as 70 feet. In wider areas, it spread out, reducing in height but increasing in width. Within 45 minutes, the South Fork Reservoir had emptied. 20 million tons of water had been released. The lake, which had stretched for miles that morning, was now a muddy basin scattered with the stumps of drowned trees and stranded boats. The dam was a gaping wound in the landscape, its center carved away, its remaining sections slumped and unstable. The wave moved downstream at speeds estimated between 20 and 40 miles per hour, depending on the gradient and constriction of the valley. It struck South Fork Village within minutes. Homes were lifted from their foundations and swept away. The village's rail station disappeared. Residents who had heeded the warnings and climbed to higher ground watched as their town was erased. Those who had remained were caught in the flood. Some survived by clinging to debris. Others were carried away. The flood continued down the valley, striking each community in turn. Mineral Point, a small rail junction, was overwhelmed. East Conemaugh, where the Pennsylvania Railroad maintained a roundhouse and repair shops, was inundated. Locomotives and rail cars were torn from their tracks and carried downstream. Wooden buildings collapsed under the force of the water. The debris mass grew larger with each mile, accumulating wreckage from the destroyed communities and adding it to the advancing wave. Telegraph operators in the path of the flood sent frantic messages downstream before their stations were swept away. At East Conemaugh, an operator named Emma Ehrenfeld remained at her post, sending warnings until the water reached her station. Her messages reached Johnstown, but by then the flood was less than 30 minutes away. Warnings were shouted in the streets. Some people ran for the hillsides. Others, disbelieving or unable to move quickly enough, remained where they were. The sound of the approaching flood became audible across the valley, a deep, continuous roar that grew louder with each passing minute. The flood wave reached Johnstown at approximately 4:07 in the afternoon. Witnesses who survived described it as a dark wall moving through the valley, 30 to 40 feet high in places, filled with debris and moving with immense force. The sound arrived first, a rumbling that built to a roar, punctuated by sharp cracks as structures upstream were torn apart. Then the water appeared, a churning mass of brown water, timber and wreckage pushing ahead of it a cloud of mist and spray. The wave struck the eastern edge of town first, hitting the Cambria Iron Works with full force. The brick buildings of the rolling mills collapsed as their foundations were undermined. Walls that had stood for decades fell inward, their masonry scattered by the current. Boilers weighing several tons were torn loose from their moorings and carried downstream like leaves. Rail cars loaded with iron ore and finished rails were lifted and tossed into the growing mass of debris. The machinery of the mills, some pieces weighing hundreds of pounds, was displaced or buried under sediment and wreckage. The wooden homes along the riverfront disappeared within seconds. Entire structures were lifted from their foundations, broken apart, and absorbed into the advancing wave. The debris mass grew exponentially as it moved through the town. Each destroyed building added its timbers, furnishings, and contents to the flood. Roofs, walls, and floors were reduced to fragments that interlocked with tree trunks, rail ties, machinery, and twisted sections of iron rail. The mass became dense and semi-solid, pushing forward with the weight of the water behind it. The downtown district, built on the lowest ground where the two rivers met, was submerged. Washington Street, the main commercial thoroughfare, was covered with water within minutes. Shop fronts collapsed. Brick facades fell into the street. Merchandise spilled from broken windows and was swept away. The wooden boardwalks that connected the buildings were torn up and carried downstream. Gas lines ruptured, releasing vapor that mixed with the mist. The smell of coal gas and raw sewage filled the air. At the lower end of town, the Pennsylvania Railroad stone bridge acted as a temporary dam. The bridge had been built to withstand the force of locomotives and loaded freight cars. Its 7 arches, each 75 feet wide, rested on massive stone piers sunk deep into bedrock. The structure was the strongest in the valley. As the debris mass reached the bridge, it began to pile up against the upstream side. Timbers, rail cars, sections of buildings, and entire houses lodged against the piers and began to accumulate. The debris pile grew rapidly. Within minutes, it covered acres, rising higher than the bridge deck. The interlocked mass of wreckage formed a temporary obstruction that held back the water. The flood backed up behind this barrier, spreading across the entire width of the valley. The water level rose. Areas that had been above the initial wave were now inundated. Homes on higher ground were surrounded. People who had climbed to second floors found the water rising past their windows. Some broke through to their attics. Others climbed onto roofs and watched as the water crept higher. The accumulation at the stone bridge became unstable. Sections of the debris pile shifted and collapsed. Objects trapped within the mass were released and swept over the bridge, only to be replaced by new debris arriving from upstream. The process was continuous and chaotic. Railcars tilted and fell. Sections of buildings rotated and tumbled. The entire mass groaned and cracked under its own weight. Fire broke out within the debris pile. The source was likely overturned stoves or furnaces from the destroyed buildings, though ruptured gas lines may also have contributed. Flames appeared in multiple locations, spreading through the dry timbers despite the surrounding water. Oil from damaged railcars fed the fire. The smoke, thick and black, rose in columns that merged with the low clouds. The fire burned through the night, its light visible for miles. The heat was intense enough to be felt by survivors on the hillsides hundreds of feet away. People trapped within the debris pile called for help. Their voices carried across the water to those on shore, but there was no way to reach them. The fire advanced through the wreckage, and the calls gradually ceased. The number of people trapped in the burning mass was never accurately determined, but estimates ranged from dozens to hundreds. Bodies recovered weeks later from the debris pile were often burned beyond recognition. In the flooded areas of town, survivors clung to whatever remained above water. Some found refuge on roofs that had stayed partially intact. Others held onto floating debris, riding the current until they could reach higher ground or be pulled to safety by those on shore. The water was cold, filled with debris that moved unpredictably, and contaminated with sewage and industrial chemicals from the destroyed mills. Staying afloat required constant effort. Many who survived the initial wave drowned in the hours that followed, too exhausted to continue. The valley filled with the sounds of destruction, the crack of timbers breaking, the grind of metal against stone, the hiss of water rushing through gaps in the debris, and the roar of the fire. Underneath it all was a deeper sound, almost subsonic, the vibration of immense masses in motion. Then, as the water began to recede and the debris pile stabilized, the sounds diminished. By evening, the valley had fallen into an eerie quiet, broken only by the crackle of the fire and the occasional collapse of weakened structures. The rain continued, steady and cold, falling on a town that no longer existed. The 1889 Johnstown flood, the day a valley went under. Chapter 1: Morning in the Valley. On the morning of May 31, 1889, cold mist hung low over the Conemaugh Valley. Clouds pressed against the ridges that enclosed the narrow basin where Johnstown spread along the riverbanks. The air carried the soft metallic echoes of the mills, still warming after the night. Rain had been falling for days, steady and indifferent, soaking into ground that could hold no more water. Johnstown was an industrial town of 14,000 people, built where the little Conemaugh River met Stony Creek. Steel mills lined the water's edge, their furnaces beginning to glow as workers arrived for the morning shift. Smoke rose slowly from brick chimneys, merging with the gray overcast. The smell of coal smoke mixed with the damp earth. Wooden homes stood close together on the flats and partway up the hillsides, their foundations just feet from the water. Boardwalks connected the main streets, raised above the mud that accumulated during wet weather. The rivers were already high. The little Conemaugh, which normally ran shallow enough to wade across, now moved fast and brown, carrying branches and debris from upstream. Stony Creek, fed by mountain tributaries, had risen past its usual banks. Puddles covered Washington Street. Water pooled in the rail yards where the Pennsylvania Railroad maintained its repair shops and switching stations. The streets were soft with mud. Children on their way to school stepped carefully around the deeper pools. The Cambria Iron Works dominated the eastern side of town. Its blast furnaces and rolling mills employed thousands of men who worked in 12-hour shifts. The works stretched along the riverbank, a complex of brick buildings, wooden sheds, rail sidings, and stockpiles of coal and iron ore. Steam engines powered the machinery. The steady rhythm of hammers and rollers formed the town's constant background sound. On this morning, as on every morning, the works came to life with the lighting of furnaces and the movement of materials. Above the town, 14 miles upstream in the Allegheny Mountains, the South Fork Dam held back a reservoir that stretched 2 miles long and a mile wide at its broadest point. The structure was an earthen embankment, 72 feet high at its center and 900 feet across at its crest. It had been built decades earlier to supply water for the Pennsylvania Canal system. Now it served as the centerpiece of a private fishing and recreation club, its shoreline dotted with cottages and boathouses where Pittsburgh's wealthy industrialists spent their summers. The dam was quiet that morning. Water lapped at the embankment's sloped face. The reservoir surface was smooth and gray, reflecting the low sky. A caretaker's cottage stood near the eastern end, smoke rising from its chimney. No one in Johnstown gave the dam much thought. It had been there for years, a fixture of the landscape, mentioned occasionally but rarely considered with any seriousness. Some residents knew it existed, others had never seen it. The distance between the reservoir and the town seemed sufficient to separate their daily concerns. The valley began its day with the rhythm of work. Mill whistles sounded at 6 o'clock, their notes carrying across the water. Horses pulled delivery carts over the wooden bridges that spanned the rivers at multiple points. Shop owners opened their doors on Main Street and Washington Street. The smell of bread from the bakeries mixed with the coal smoke. The rain continued, steady and cold, tapping on tin roofs and pooling in the ruts of unpaved streets. The rivers kept rising, but they had risen before. Flooding was a regular occurrence in spring. The water would crest, then recede. The mud would be shoveled away. Life would continue. By mid-morning, the rain intensified. The sky darkened to a uniform gray. Visibility dropped. The ridges that enclosed the valley disappeared into the low clouds. Water ran down the hillsides in streams that had not existed the day before, carving new channels through the thin topsoil. The sound of rain on rooftops became a steady hiss. People moved quickly between buildings, collars turned up, shoulders hunched. The streets emptied except for those whose work required them to be outside. At the South Fork Dam, the reservoir continued to rise. Water crept up the sloped embankment, inch by inch, as rain fell directly into the lake and as streams from the surrounding mountains poured into the basin. The surface, now pockmarked by rain, moved in slow currents toward the spillway on the eastern end. The spillway, a channel cut into bedrock, was designed to carry overflow away from the dam. But the spillway was partially obstructed, and the water could not drain as quickly as it arrived. In Johnstown, the morning passed. Workers at the Cambria Iron Works continued their tasks, moving between the heat of the furnaces and the cold damp of tea. When daylight returned on June 1, the scale of the destruction became fully visible. The center of Johnstown was unrecognizable. Where buildings had stood, there was now mud and scattered debris. The streets had disappeared under layers of sediment. Twisted sections of rail line lay across what had been Washington Street. Sections of machinery from the Cambria Iron Works were embedded in the ground hundreds of feet from their original locations. The wooden bridges that had connected the town were gone, their stone piers left standing in isolation. The debris pile at the stone bridge still smoldered. Smoke rose from its interior, where the fire continued to burn in pockets of trapped material. The mass covered 30 acres and rose as high as the bridge deck in places. Recovery workers who approached it reported the smell of burned wood and something worse, the unmistakable odor of burned flesh. Bodies were visible within the wreckage, some partially exposed, others buried deep within the interlocked timbers and metal. Extraction would take weeks. The riverbanks were lined with debris fields that stretched for miles. Furniture, clothing, tools, photographs, and personal belongings were scattered across the mud. Some items were identifiable, bearing names or addresses that allowed them to be returned to survivors. Most were damaged beyond recognition or separated from any context that would reveal their origin. The mud itself was contaminated with industrial waste from the destroyed mills, chemicals, oils, and heavy metals that would remain in the soil for decades. Rail lines into the valley were severed in multiple locations. Bridges were gone. Track sections were twisted or buried. The Pennsylvania Railroad's repair shops at East Conemaugh were destroyed, along with much of the equipment and rolling stock stored there. Initial relief efforts were delayed by the loss of communication and transportation infrastructure. Telegraph lines were down. Roads were impassable. The valley was isolated. By June 2, the first relief trains from Pittsburgh arrived at the edge of the valley. They carried supplies, medical personnel, and workers organized by relief organizations that had mobilized within hours of the first news reaching the city. The trains could not proceed beyond the break in the line, so supplies were unloaded and carried on foot or by wagon over makeshift roads. Temporary shelters were established on the hillsides above the flood zone, using tents and hastily constructed wooden structures. Field kitchens were set up to provide food for survivors and relief workers. The documented death toll from the flood reached 2,209 people, though the actual number may have been higher. The transient workers employed by the mills and railroad often lived in boarding houses that kept incomplete records. Some entire families were lost, leaving no one to report them missing. Bodies were recovered for months after the flood. Some were found miles downstream, caught in debris or buried in sediment. Others were never found. Identification was difficult, particularly for those recovered from the fire at the stone bridge. Many were buried in mass graves, their identities unknown. The physical recovery took years. Debris removal required months of manual labor. Workers used hand tools, horses, and eventually steam-powered equipment to clear the wreckage. The stone bridge, which had trapped so much debris, was eventually cleared but remained standing as a reminder of the disaster. The Cambria Iron Works began reconstruction within weeks, driven by the need to resume production and maintain employment. Temporary structures were erected while permanent buildings were designed and built. By the end of 1889, the mills were operating again, though at reduced capacity. Homes were rebuilt, often on the same foundations. Residents returned to their property and began reconstruction using whatever materials were available. Some received assistance from relief organizations or low-interest loans from local banks. Others rebuilt entirely on their own. The town's layout was largely preserved, with streets and property lines following their original paths. The decision to rebuild in place, rather than relocate to higher ground, was driven by practical considerations. The location of the mills, the rail lines, and the property ownership patterns that had been established over decades. The flood prompted changes in American engineering and disaster response. It led to increased scrutiny of dam construction and maintenance, particularly for privately owned structures. Professional engineering organizations began developing standards for dam design and inspection. The concept of liability for infrastructure failure was tested in legal cases that followed the disaster. Survivors and property owners filed lawsuits against the South Fork Fishing and Hunting Club, seeking compensation for their losses. The cases were ultimately unsuccessful. The club's members were never held financially responsible, as the courts determined that the flood was an act of God rather than a result of negligence. The broader impact on dam safety practices was significant. States began implementing inspection requirements and oversight mechanisms for large dams. Engineering standards were developed that specified design criteria for spillways, embankment materials, and maintenance protocols. The lessons of the Johnstown flood influenced dam construction for decades, contributing to the development of more robust safety practices across the United States. The valley returned to a semblance of normalcy over the following years. The mills resumed full operation. The population stabilized and eventually began to grow again. New buildings rose where destroyed ones had stood, but the flood remained part of the community's identity. Survivors carried the memory of that afternoon for the rest of their lives. Photographs of the destruction were preserved and widely circulated, becoming part of the historical record. The rebuilt town continued its industrial work, smoke rising again from the mills, the rivers flowing within their banks, confined by rebuilt embankments and bridges. The South Fork Dam site remained empty. The breach in the embankment was never repaired. The reservoir basin became a field dotted with stumps of drowned trees. The club's cottages were abandoned or dismantled. The site became a place of pilgrimage for those who wanted to see where the disaster had originated. Over time, vegetation reclaimed the area, but the scar of the breach remained visible in the landscape, a permanent mark of what had occurred on May 31, 1889. The disaster became a reference point in American history, cited in discussions of infrastructure failure, engineering responsibility, and the consequences of deferred maintenance. The weight of what occurred never fully lifted from the landscape or from the memory of those who experienced it.